Hello, welcome to Topper Machine. I'm Josh Topper, and today's job we are going to be doing on the Lucas horizontal boring mill. All right, so here are the parts. They are just over 4 feet long. They are a tube with a plate welded on the end. They get some holes drilled in them. There are 2 different styles here. One has a plate on the side as well. These got to get milled off true and then drilled. And I've already done one. I already have my setup. Here's the first one. Both ends, it's trued up to length. And what we are using is a big 8-inch face mill. So I'm already set up. We'll get the first one, the next one loaded up here and clamped in, and then I'll show you the whole setup. All right, well, I got the first one clamped in here, well, second one, I already did one. And it's sitting up on 246 blocks. I've got my angle plates back here, and then clamp it. And what I've done here, maybe you can see it down here, I set up basically a tail stop. And it butts up against this stop, and that gives me a positive end placement. So now we're in a good spot. We'll bring over the mill. We'll start it up, touch it off, and then bring it in about 50 and face this end off. Take it in about 50 thou for our first pass. There's our first pass. That's very smooth. And the chips are coming off pretty light. I were coming off blue earlier. I had my feed rate up where I wanted it, but I was getting too rough of a surface finish, so I backed it off a bit. I'm feeding at, right now I am feeding at 54 thousandths per revolution of the cutter. I was up at 67, but I was just getting too rough of a finish. I didn't like it. So, but we got to take at least another pass. We got to get 100% cleaned up, then we flip it around and do the other end to length. that's a pretty decent finish for as coarse as I'm feeding this. It's cutting very nice. So now we'll go ahead, flip it around, and then face the other end. All right, so I'm all flipped around, and just looking at this plate, I can see it's a little crooked, so I'm gonna have to touch off. I've got a 0 set on an indicator down below, but I'm gonna have to touch off so I'm not taking way too much in a pass. And then we'll take it down close, measure it, and then see where we're at and finish this thing off. You know, the boring mill is a lot of fun, but you really have zero visibility because the way of the cutter and everything, you don't get much for good visibility, but she's definitely cutting a taper. That thing was not on there square. Alright, so there's our first cut. We cut a little deeper here, but she was definitely on there crooked because this all didn't clean up. So we'll go ahead and take another pass, and then we'll see where we're at. Finished up pretty smooth. Let's measure this thing up and see where we're at. All right, so this is my 50-inch Starrett 123 vernier caliper, and these parts finish off at 49,880, so 5 thou over 7/8, 49 7/8 plus 5 thou. That's the finished length, and I have a problem. My 48-inch caliper is not big enough. So we go to the bigger box. And we pull out the 72-inch, actually 74, Starrett 123 vernier caliper. Now, I just bought this thing for these particular parts. I ran them one time. This is like the 4th batch now, and my 48 just wouldn't cut it. So I picked this up just for doing these and anything in the future. $49,955, so $75 to go. So since I've got 75 to go, I'm going to take that in one pass. All right, so we're going to go ahead and take that 75 in one pass. And at my feed rate, that's going to cut just fine. Alright, so while that's cutting, I know a few of you have got questions about the big caliper. You know, what does something like that cost? Well, I found out recently that a 72-inch Starrett 123 is about $20,000. I paid nowhere near that. I got a smoking deal on eBay. I had it delivered for under $2,000, so I think I did very well. I had it calibrated, it came out perfect, so definitely a good, sound investment. There's our final pass. I'll grab the caliper and measure that one more time. $49,880, right on. Perfect. Means my stop is in the right place. So we can go ahead and just keep surfacing all of these to length, and then we'll reset up and do the ones with the plate on the side, and then we'll go, well, we're gonna drill the end plates first, and then we'll space the side plate and drill those. So I want to address this real quick. I set up these angles here as a staging area for strapping and getting it on the mill. These things are not very heavy. They really don't weigh much at all. The problem is getting it over there is going to be hard on my back. So I set it up here, I stage it, lift it with the crane, bring it over, set it into place, clamp it down. Then just pick it up, bring it back over here where I can easily pick it up with a straight back and not hurt myself. So this is something I came up with about halfway through the first batch of these I did, trying to figure out how to get them out there safely, and that was the best option I came up with, and it's worked really well. right, so our last pass is done here. This is the last part. I'll get the big face mill out of there, get the drill chuck up in, and then we'll start drilling our holes. All right, so before I started facing all these, I indicated and set my zero off of my angle plate here and my 246 block. So I have my height, and then I had to come up half the distance of this box tube to get center, but I also have to indicate a 1/4 inch off of the angle plate because the zero is actually a 1/4 inch from the end of this box tube. So set that zero, and then we start drilling our holes, and it gets 4 531 holes on each end, and then a 1/2 inch drilled and reamed hole here and here. And then we flip the part around, but I also have to orientate it, so when I rotate it around, obviously this plate will be over here. I need to roll it, get this plate back over here so that I'm exactly the same again both ways. All right, so I'm in position here for my first hole. We're gonna be using the anchor lube. I pretty much switched over to this exclusively, and what's really nice is you can get it in this little cup with a brush. Works really well. So let's get this drilled. Now we change out to the reamer. And I'm going to run this just the same speed. A little anchor lube and Alright, now we get the flipper around. And if you remember how I said about the orientation, once we get it spun around, then I got to flip it over to keep this plate on the back side for location so that everything's accurate. So now that I got it in place, basically reverse the whole process. I'll do the tap or the reamer first because I'm already in position for one of the reamed holes. I don't have to relocate, so I'll switch out to my drill. And then drill, ream, and then drill for the larger size on the outer corners. All right, now I just need to chamfer the holes, and I can do that all pretty easily with these angles I got up here because it gives me something to push against. Alright, so here's a cool tool that I saw Adam Booth using quite a while ago. It's an air-powered chamfering tool. It uses a little carbide insert and a bearing, kind of like a router. And you just put her up there and run her flat against your plate. Now 1 down, 9 to go. I'll get the last one and then we'll set up for the next step. All right, well, this is the last one of this end. Now I'm going to tear down, switch my setup, and get everything indicated in to do that plate on the side. Well, here's my setup. Pretty basic, pretty simple. I got a angle block over here for a stop. I got my angle blocks back here for stops. Sitting up on 2, 4, 6 blocks to get me up off the table for milling this, and just clamped in 2 places, and it's rigid. And I've done quite a few this way so far. We got our big face mill back in the spindle, locked in. Now you're probably wondering why I just run the milling and then switch out and do the drilling, you know, switch out the part on the table each time. It's because the Morse Taper 6, it's so much more work to set up. It's just easier to pull the part off, switch it out, especially when there's a bunch like this and they're not that terribly heavy. So we'll do the milling operation on all of them, come back and then do the drilling. Okay, so you noticed how I was taking a much healthier cut on this. That's because I have a much better setup on this. There's a lot more rigidity out here, whereas before I was sticking out the table away. We had a little bit of flex from the bar. I couldn't get enough support out as far as I needed it. So that's why I've taken a much better cut on the center plate than I am here. So now we got to measure this and see where we are. We need 3/4 inches from here to here. And here I'm just going to use my Starrett depth micrometer. I'll touch it off on the face and bring it in till touch our plate here, or our tube. And we're at 898 thousandths, so we got a little ways to go, just over 1/8 of an inch. So I took 100 thousandths on that last pass, and look at that, I got 48 to go. I don't know if you can see that at all. And remember, when you're running these inside or depth micrometers, everything's backwards. So the first time I ever used one, I screwed up the part because I was reading it wrong. And now I'm always cautious about that. So we got 48 thou to go, that'll be our final pass. Well, this one's milled to size. I'll go ahead and get it off. I'll get the next one up there, get those done, and then we'll set up for the drilling and then the tapping. All right, we got that all milled up. Now we'll switch out to the drill and get these 6 holes drilled and then tap them. And these parts are done and ready to leave. All right, so I'm just going to show the drawing here, at least what I can show you. And we're drilling these 6 holes and then tapping them. They're half 13, so at 22,690 and 27,190. So we set up, drill these, and then we'll go ahead and move it over to the drill, the AV drill, to tap them. All right, go ahead and use some of our anchor lube and we'll start on drilling. All right, so I'm over here at the AV sensitive drill, and I don't like to tap on the boring mill just because the motor controls on that are not finite. It's not like a clutch or something you shut off and it'll just stop. It coasts sometimes the brake feature works at the right time, sometimes it doesn't. It's iffy, and I haven't had the real desire to tear into the electrical and figure out how to make that more consistent. But we use the AV drill because I can start it up. I've got this pedal that gives me an instantaneous reverse. Now that's a little fast for tapping. I'm gonna knock her down to 150 for tapping this 1/2 inch, and we'll go ahead and tap these. All right, so I got 150 RPM, put a little anchor lube on our tap, and away we go. All right, well that's the last one. And you notice how I use my drill chuck. You saw it slip in there a little bit. That is a good feature. If it can slip a little bit, it means it's not gonna break. I've had to set up before where I've had them rigid tap in a tap holder, and I've snapped them when it bound up a little bit. This will give me a little bit of give, but still drive it properly. All right, well there you have it. The first one of that style done. I got 4 more to do. I just got word the truck will be here in an hour to pick these up, so I gotta get moving. So I hope you enjoyed the video, and until next time, get out in your shop and get it done right the first time.